One of the main applications of finding the inverse of a matrix is to find out the solution of system of linear equations. Later we shall see about this topic in depth, but since we are talking about this inverse, matrix inverse, here I'll just explain you with some few examples. We are not going to go in depth in detail about this, but later we shall again go about this after finding out the rank of a matrix. Since we already know how to find out the inverse of a matrix, I'm just taking this small topic here. Later we shall extend it. Okay, so here with some examples, let's see this topic. So what I mean by finding the solution is, if we have linear equation, already we have seen the Cramer's rule, right? In Cramer's rule also we try to solve some of the equations, linear equations, using the Cramer's method. But instead of using the Cramer's method, here we shall use a different method using the inverse. Let's say this: if we have n equations, let us say we have n linear equations like this of form ax1, some ai1 x1, ai2 x2, so on, ain xn equal to bi, where x1, x2, so on xn, these are all the n variables, and we have n equations. I didn't write all the n equations, but assume that we have all n equations. I is running from 1 to n, which means a11, a22, a3, a1n for the first one, and for the second equation a21, a22, so on a2n, and for the third equation a31, a32, so on a3n equal to b3, like that. Let us say we have n equations here. Now as I have already shown you in the Cramer's rule, we can write these equations, these n equations, in place, in terms of a single matrix equation like this: ax equal to b, where a is nothing but collection of quotients. So all the quotients of the variables will be written here, right? So this is all the quotient matrix, and then this is the variable matrix, and this is the right hand side. So whatever you have here, bi, right? Just remember that this all the elements of one column in this matrix, they all are quotients of the same variable in the corresponding equations. For example, a11 is the quotient of x1 in the first equation, and a21 is the quotient of the second one, right? This is the quotient of x1 in the second equation, so on. an1 is the quotient of x1 itself in the nth equation. Therefore, if you see one column, all of them corresponds to the same variable, right? Similarly, this one completely corresponds to the x2, and all of them correspond to the xn. So just what you can do is, whenever some equations are given, write them in such a order, such a way that all the variables will be in the same order in all the equations. After writing that, you can extract the corresponding quotients and then put them in the quotient matrix, and then you can take the you can write them this way, right? So now I told you that the equations can be written like this. The matrix equation can be written as ax equal to b. Now assume that A is a non-singular matrix. So non-singular matrix means determinant of A is not equal to 0, and therefore A inverse exists. Now we can apply this method only when A is non-singular matrix. So we shall later study about what happens if A is a singular matrix and what happens if it is of so and so order. We shall see them later. Okay. So for now, I am just going on based on the assumption that A is a non-singular matrix, which means A inverse exists. Under that assumption, I will be solving the questions. Okay. So assume that A is a non-singular matrix, which means that A is not equal to 0, then A inverse exists, right? We already have this equation Ax equal to b. Now I am trying to multiply both sides of this equation with A inverse. I multiplied it, right? And then once I multiply A inverse with A, we know that the result is nothing but in, identity matrix, right? In. Therefore x equal to A inverse into b. So we found out that the values of the variables can be found out by multiplying A inverse with b. Direct, easy, isn't it? So even though we have 3 equations and 3 variables, we can get a 3 by 3 matrix, and finding out its inverse and then multiplying with b is going to give us all the values. Only glitch is that you are supposed to know that the matrix is non-singular. Okay, and one good thing about this method is you are not just going to get one solution. Whatever solution you get is unique also. What do I mean by unique is, if you get one solution based on this method, there is no way there can exist some other solution which is different from the solution you got. So what I mean to say is, let us assume that you got a solution x1. X1 means some values for all these. You got one solution for all these variables, and later let us say someone has got other solution by using other method x2, and both of them are supposed to be solutions for this, isn't it, for the same equation. What is the equation? Ax equal to b, right? Then what does it mean? If I substitute in place of x this x1, this equation should be satisfied, and x2 in place of x, this equation should be satisfied. It means that a x1 equal to b should be valid, and a x2 equal to b, it also should be valid, right? So if you look at the right hand side, both are b's, right? Therefore you can equate the left hand sides, these two. So how can I equate them? Ax1 equal to ax2, and then you can multiply from the left hand side using A inverse. So if I multiply A inverse here and A inverse here, then this one will become in into x1 equal to in into x2. So what did we get? Whatever method you follow, right, you are supposed to get only one solution, which is unique. Therefore, as long as A inverse exists, you are going to get a unique solution. Later we shall see this method, or later we shall examine this matrix A in detail after I discuss about echelon form and then rank of a matrix. We shall again see the same concept, solving the system of linear equations. For now, let's keep it simple. Since we are talking about the inverse of a matrix, I just wanted to add this topic so that it is relevant, but then in detail we shall discuss it later. Now we shall see some examples on this. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.